Dear students, now let us learn about types of spectra. So there are two types of spectrum, that is absorption spectrum and emission spectrum. Now let us understand what are the how do you get emission and absorption spectrum and what are the differences between them. Now before we step into emission or absorption spectrum, now first of all let us understand how do we get a spectrum basically. If you take hydrogen atom, so in hydrogen atom, there is only one electron. So there is a nucleus here and there is an electron. Now wherever the electron is there in the ground state, that is known as lower energy state. The electron will be always in which state? Lower energy state, that is also known as ground state. So whenever the energy of electron is lesser, it is said to be stable. Now, what happens as you move away from the nucleus? See, these are the different energy levels. These are the different energy levels, the yellow color line. So, each energy level corresponds to different energy. As we move away from the nucleus, the energy of the orbital increases. Therefore, this is an example for higher energy level. Suppose for this hydrogen, we are supplying energy in the form of radiation, H nu. I am going to supply energy to it. When we supply energy, the electron gains energy. As a result, it moves from the lower energy state to higher energy state. So the energy supplied in such a way that the electron will not move out of the atom. Instead, so from the lower energy state to higher energy state, it goes up. Therefore, the electron was here. Now the electron will be shifted to higher energy state. That I am going to represent it as this. This is an electron. So this is there in higher energy state. Whenever the electron having higher energy, it is said to be unstable. This is unstable. Energy rich species is always unstable. So as a result, it will come back to normal. Now 1 minute. I told you electron gains energy, right? So when the electron shifts from here to here, it absorbs certain amount of energy. When I say absorb certain amount of energy, let's say you are supplying energy between 400 to 700 nanometer, 400 to 750 nanometers, out of which let us assume that it is absorbing energy from 400 to 420, 400 to 420 nanometers. So if I look at the photographic plate and if I observe how much of radiation being absorbed by the electron, then the resulting spectrum which we get, we call it as absorption spectrum. So in absorption spectrum, what we do, we just find out how much of or what is a wavelength range, or it can be one number or it can be range, which is absorbed by the electron in order to reach to higher energy state. So if you observe that in the photographic plate, the resulting spectrum obtained, we call it as absorption spectrum. Since we are observing the amount of radiation which is absorbed, whatever the radiation absorbed are there, so that appears as a bright spaces like this, bright bands. So this blue and this green red color, all these corresponds to the wavelength of radiation which is absorbed by the molecule. Corresponds to wavelength absorbed by the atom. It can be an atom or it can be an ion or it can be to a molecule also. Okay, so this bright spaces corresponds to the wavelength of absorbed radiation. What about this dark spaces? Dark spaces corresponds to the emitted radiation, wavelength of emitted radiation, that won't appear, wavelength of emitted radiation. So this is how we get the absorption spectrum. So you have an electron that absorbs energy. That absorbed energy corresponds to a certain wavelength, or it can be range also. So those range of wavelength appears in the photographic plate. Okay. Therefore, in case of absorption spectrum, bright band separated by dark lines. So what's the observation? For uh, absorption spectrum, you have a bright bands, bright bands separated by separated by dark lines, right? Dark lines. That's a characteristic of absorption spectrum. So this is the bright bands. This is a bright band, and this is known as dark lines. Dark lines. So now, how do you get the emission spectrum? If you consider emission spectrum, the same example I'll take. The electron absorbs energy, goes to the higher energy state. Higher energy state is unstable, due to which it comes back to normal by emitting radiation, right? It will come back to normal by emitting radiation. If I find out what is the wavelength of emitted radiation, so what is the wavelength of emitted radiation on the photographic plate? They appear as bright lines. They appear as what? Bright lines. Only what is the emitted radiation that would be appearing on the photographic plate. Then the remaining absorbed one will not appear. So that appears as dark dark space. Therefore, in case of emission spectrum, we observe only the wavelength of emitted radiation. Therefore, if I consider the emitted emission spectrum, it will have bright lines, bright lines separated by, these are the dark bands. These are the dark bands. Dark bands. What are these dark bands corresponds to? The wavelength of absorbed radiation. We are not considering it, that's why they appear as dark bands. Therefore, the characteristic of emission spectrum is bright lines, bright lines separated by dark spaces, dark space. Therefore, what are the examples for emission spectrum? So if you take any spectrum of atom, like atomic spectra, so that's an example for emission spectrum. Okay, if you consider rubidium, cesium, or sodium, or any other element, and just find out what is the wavelength of emitted radiation, the resulting spectrum will be emission spectrum. And one more important characteristic is, so if you consider this example itself, have taken hydrogen absorption spectrum and hydrogen emission spectrum. So both of them are opposite to each other. See, in case of emission spectrum, wherever dark bands were there, okay, that corresponds to the wavelength of absorbed radiation that will appear for absorption spectrum. That means in absorption, we consider the wavelength of absorbed radiation. That's why there is a bright bands there. In case of emission, we observe only the wavelength of emitted radiation. That's a major difference. Thank you.